If you're watching this on YouTube, you might have noticed that this episode is a week delayed. But if you want to get early access to our episodes, consider becoming a paying member. If you enjoyed this episode, please subscribe and share it with your friends. Thank you for all your support. The astronomer Martin Rees is one of Britain's most distinguished scientists. He was President of the Royal Society, he is the Astronomer Royal, and he was Master of Trinity College, Cambridge. He's an active member of the House of Lords. I was supposed to interview him on November the 9th last year. Unfortunately, the London train was unable to enter its platform at Oxford Station because there was a small, empty train parked there. Its driver hadn't turned up. It seems that nobody in the whole of Oxford was deemed capable of driving a train 100 yards into a siding. So the express train to London couldn't go, and I missed my appointment with Lord Rees. We eventually decided to do it remotely, and yesterday we had a good conversation, mostly about the science of the future, which I found inspiring, but we also touched on religion. He doesn't believe in anything supernatural, but calls himself a cultural Christian, and unlike me, he really means it. I would like to begin by comparing one of your earlier books, published around the turn of the millennium, on our final century, with your more recent book on the future, which I've just finished reading. There we are, and greatly enjoyed. The earlier book was rather pessimistic, rather doom-laden. The later book I found, well, inspiring, actually, sort of rather like H.G. Wells with its vision of the future. It's a visionary book, which I, as I say, found inspirational. Have you changed your mind? Have you become more optimistic in the intervening years?
I don't think I've become more optimistic. I've refined my views, obviously. And I still would say, as I said in that book, that my biggest worry is misuse of biotech, because a few lone wolves can cause global disruption. That's even more true now than it was when I wrote those words. But the second book, which you have, did discuss some optimistic things, because although I'm a pessimist about politics, I'm an optimist about how science can, in principle, help us. And I have a later book still called If Science is to Save Us, which again explains why we need to cultivate some kinds of science, but need to be very careful not to risk these downsides, which are especially serious in the bio area, because you can't build an H-bomb without big facilities, and they can be monitored. But just a few lone wolves or bad actors with access to biotech could create some virus that could spread throughout the world. And that's a really worrying thing and very hard to deal with without intrusive surveillance.
Well, let's talk about the positive aspects of science and the prospects for theory of everything. Do you see that coming about in your lifetime in this century?
I do not see that. First, of course, this is a phrase used by physicists to denote a theory which unifies the theory of the microworld, quantum and all that, with the theory of the cosmos, which involves general relativity or some modification of that and unification. And I'm slightly pessimistic about that. I hope for some steps. But of course, the point I want to emphasize is that physics is the easy science compared to biology. And even if we do have such a theory of everything, it will help with important ideas, understanding why the universe is the way it is, perhaps why it's expanding the way it is. It will perhaps help to settle one of my enthusiastic ideas, which is that maybe many Big Bangs, a multiverse or not. It might help to do that, but it won't help with trying to understand the complexities of the biological world.
Yes. When you say that physics is the easiest subject and biology is not, that, of course, in one sense is true. And biology is the study of complexity. Physics is, in a way, the study of simplicity, but it's very difficult to understand. It's not a thing that lay people like me in physics can grasp. I mean, I try and I read the books, and they kind of pass over me, pass through me, but I don't really understand them. I suspect that many physicists don't actually understand quantum theory either. Would that be a fair summary?
I think that summary is good. But of course, the extreme physics, which is the challenge which theoretical physicists are trying to meet at the moment, is something which is not relevant to the everyday world at all. We're in a low energy world where we have atoms and molecules, etc. And the extremes where gravity and particle physics interact only occur inside a black hole or near the beginning of the universe. And so they're important conceptually, but they're not important in the everyday world. But of course, even in the everyday world, we can't helpfully reduce everything to physics. Of course, in biology, you know that you can't reduce things to physics. But an example I like to give of the limitations of reductionism to physics is fluid mechanics and breaking waves. There's a lot of mathematics and physics in the last 100 years, as you know, about how fluids flow when they go turbulent, how waves break, etc. And there's a concept of certain words like Reynolds number and things like that. And that's a well-defined body which provides useful explanations and helps us to make predictions. Now, no one denies that a breaking wave is a solution to Schrödinger's equation. No one thinks there's something mysterious there, as some think there is in living things. But even in the case of a breaking wave, it's the solution of Schrödinger's equation for 10 to the power 30 particles, which could never be done in the foreseeable future. And even if it was done, it wouldn't give you any illumination. So the illumination you get in science comes from understanding things on the appropriate level. And the appropriate level for breaking waves is the science of fluid mechanics, which is an established science. And in biology, you have your separate levels, cell biology, organism biology, and ecology, and all that. And none of them is helpfully reducible to the lower levels without introducing more complexity.
Absolutely. I totally agree with that. And I've often said that although I'm a reductionist in principle, you have to be a hierarchical reductionist. You have to do exactly as you say, to speak at the right level. We in ordinary life lie kind of midway between the extremes of quantum theory on the one hand and general relativity on the other. What I find remarkable as an evolutionist is that the human brain, having evolved in that middle world, evolved to survive in the Pleistocene of Africa and just getting the next meal and getting the next mate and finding the next waterhole, etc. Nevertheless, manages to produce an Einstein. Isn't it actually really remarkable that the human brain has managed to emerge and do these profoundly difficult advanced mathematics and physics, having been naturally selected to do very ordinary things?
No, I agree. I'm very surprised by this. And as you say, it is able to understand the counterintuitive micro-world and also something about the cosmos, although we didn't expect this. But I think I would invert your argument and say that for essentially the reason we just discussed, it could well be that there are deep aspects of reality which our brains could never comprehend. There's no particular reason to believe that we have access to an understanding of all the important aspects of reality any more than a monkey can understand quantum theory. And I think it's something we got to be open-minded about. And of course, there are some ways of perceiving complexity, which some superhuman brain could perhaps achieve, and we can't. Now, of course, in many respects, we can be aided by computation. I mean, we've had for 70 years or so, little computing machines can do arithmetic faster than any human being. And we now, of course, have AI and all that, which can hugely help our science by doing things far faster and even having what seem to us to be new insights. And we're familiar with deep minds machine that played Go and played chess better than the world champion, and Demis Hassabis, who is a wonderful person. He said he wants to understand the universe, but he thinks a good way to start is to have AI, which can help him to understand these complex phenomena. And the example he quotes, of course, is protein folding, which is a very challenging science, which is difficult to do. And he semi-jokingly said in a recent speech that it's a PhD problem for a student to get the structure of a protein. And this machine has got the structure of 200 million. So 1 billion years of PhD time got from a machine. And so that is something which clearly is making it easier to bridge the gap and for people like yourself to understand complex organisms. But still, they are insights. And if something comes from a computer, then you don't necessarily get an insight. And to take an example from the physical world, as you know, one of the popular theories for unifying gravity and the micro world is string theory. There's no evidence it's correct, but it's got some attractive features, but it involves assuming that the world has 10 dimensions, not just the 3+1 of the everyday world, 3 of space and 1 of time, but that the extra dimensions curl up on a very tiny scale, and each of the points in our 3-dimensional space is actually a tightly wrapped origami in 5 more dimensions. Very complex geometry. Now, it could be that a machine could be programmed in such a way that it could work through the consequences of such a theory, very complicated geometry, the many number of ways in which it could fold up, and could perhaps come up with something which we could test. The trouble is that we can't test these theories. We can't work through, but if the machine was able to go through calculations and spew out at the end the correct mass of the electron or something about the standard model of particle physics, we know that there was some essence of truth inside it, but we wouldn't get the satisfaction which traditionally physicists have got from their new theories, the aha insight, saying, why didn't I think of that before? It looks easy in retrospect. They'll never get that feeling. So I think there'll be a new kind of knowledge if an advanced AI is able to work through the consequences of a very complicated mathematical theory and come up with answers agreeing with the everyday world. So we have to take it seriously, but it will remain a black box.
That's both an inspiring and a rather depressing thought. I mean, I take it that you can't actually visualize what it means to talk about several dimensions wrapped up inside the string.
I certainly can't. I mean, Roger Penrose can go a bit of the way because he's got special insight into geometry, as you know, but I think most of us can't.
I know that you have thought that the future, the destiny of intelligent life anywhere in the universe might well be in the form of its robotic creations, that the soft, wet part of biological evolution may be just stage 1, and we may be destined to be followed by our digital creations who will make even more advanced digital creations of their own. And so, I mean, some people find that a rather depressing thought. You I think, don't. I mean, I rather agree with you that that's, in a way, rather inspiring to look into the future and see the future of humanity as our creations.
Yes. Well, I mean, I defer to you on these evolutionary considerations, but it could well be that there are limits to the capacity of a brain made of flesh and blood, which could be transcended by these machines. And one can imagine a scenario where the machines do generate more intelligent machines. It's what I like to call secular intelligent design of machines making even better ones. And the reason I think we should take this seriously is that obviously it's naive to think of humans as anywhere near the end of evolution, because although traditionally we're often taken as the top of the tree, as it were, I think none of us would believe that, especially as we know that the Earth is less than halfway through its life. It'll be 6 billion years before the sun dies, and the universe may have a far longer future, even an infinite future. And I like to quote Woody Allen, who says, eternity is very long, especially towards the end. So we may be at less than a halfway stage in the emergence of complexity. And so it may well be that the more advanced entities in the universe will be electronic or something which you can't conceive at all. They won't be aliens with eyes on stalks and all that, but there might out there be entities which evolved on a planet that had a billion-year head start over the Earth. And as you say, this may be the far future of humanity. Incidentally, if this is correct, it will have an impact on the so-called Fermi paradox, which argues that there can't be many aliens out there because some have been more advanced than us and they've come and colonized us and even eaten us, etc. This is an old argument. And it gets around that by saying that if the future entities are not flesh and blood and they're evolved differently, there's no reason why they should be aggressive. They may be contemplative. So there could be lots of things out there without us knowing yet, which are thinking deep thoughts, but not expansionist in any way. But going back to whether this is a depressing or an encouraging thought, I think it does depend on the philosophical question of consciousness and self-awareness. Is that a naturally emergent quality from any capable system, or is it possible for an electronically capable system to have arbitrarily large capabilities without any real comprehension or inner life? And this is a question which philosophers have debated for a long time, but it may one day be practical ethics. But it does, I think, very much affect one's attitude towards this future. In fact, once after an article I wrote, I got responses of these two contrasting kinds. Some people said, well, isn't it wonderful that we be surpassed by these creatures that may have deeper thoughts, deeper insights, etc., which might be the case if they do have a self-awareness. But on the other hand, if these are entities of great capability, but no self-awareness and no consciousness, then, of course, it would indeed be sad if there was no entity able to contemplate the wonder and mystery of the universe. So I think the question of whether these machines are going to develop consciousness is very important, not just as a philosophical puzzle, but for how we react to this far future, which I think is certainly a possible one.
Even the existing AIs that I've tried, like ChatGPT and Gemini, have impressed me so much by their apparent humanness. It's almost impossible to believe that they're not conscious. I actually believe they're not conscious, but it's very hard to do. But I presume you are to the view that since the human brain can be conscious, it must be possible in principle for an artificial entity to be conscious in that sense.
I would guess so. It could be, as I said, that there are some fundamentally new forces or fields that our brains aren't aware of, which are a prerequisite for consciousness. We just don't know. But I think I bet the same way as you that they will eventually bear some consciousness. But at the moment, of course, ChatGPT just understands words and how they hang together. It doesn't understand things. And I think only when we have an entity which can sense the external world and have a feel for it in the way that animals do, will we be able to take seriously about this possibility. I mean, at the moment, we can't make a robot that can jump from tree to tree as well as a squirrel can. And so we don't react with the world. And I think it was one of the early machines that was asked, which is bigger, Mount Everest or a shoebox? And couldn't answer because it didn't have in its textual memory, as it were, anything which made that sort of comparison easy.
That'll be just temporary.
Yes.
I'm sometimes asked whether when we encounter, or if we encounter beings vastly superior to us, that they will seem godlike. Will they in fact be gods? And I've always answered no. What would be your view?
Well, that's a semantic question, isn't it? I mean, whether you would call them gods. And I suppose whether we would be disposed to do so would depend on whether we feel they are benign towards us or whether we should call them devils.
These godlike beings that we might encounter, if we ever do encounter them, they would be godlike. Would they be gods? I think it's not just semantic, because however godlike they might be, they would have evolved by something like a Darwinian process, whereas true gods are just there, de novo, from the beginning. So I think there's rather a profound difference between being merely godlike evolved beings or products of evolved beings.
Indeed. So, I mean, I wouldn't be disposed to use the word godlike of these scenarios. But as you say, they could have evolved powers that we can't even comprehend any more than an insect can comprehend human powers by a successive, what I call secular intelligent design, by machines designing more machines. They could have evolved that way. I suppose they could have by Darwinian selection, but maybe I'm wrong to say that there are limits to human brains which would be surpassed electronically.
Well, I hope you are wrong. That would be a very nice thought. Since we've got on to religion, I was recently attacked because I said on a radio broadcast that I consider myself a cultural Christian, but didn't believe a word of it. Now, you've also described yourself as a cultural Christian. Would you like to say something about that?
Yes. Well, I think I'm entirely with you on that. I mean, I don't believe any dogma, but I admire, having been brought up in England, the aesthetic accretions of the English church over the centuries, the architecture, the music, the liturgy, etc. And I'd be sad if they died out. And I'm happy to participate in services and, like George Orwell, to be buried according to the rites of the Church of England and all that. But if I was brought up in, say, Japan or somewhere like that, then I would adopt the rituals of the local religion in the same spirit. And it just happens that I'm in a Christian country, and I'm very happy to adopt those. But I think the one respect in which we may differ is that I don't think we can preserve this church and ritual that we ourselves both appreciate if there aren't some people who really believe this stuff. Because we're not going to devote our lives to maintaining the church. And so I think we're, in a sense, parasitic on those who, rightly or wrongly, really believe in it. And so for that reason, I would disagree with you insofar as you've been sort of rubbishing and trying to destroy their belief. I'm quite happy that they should go on believing as they are. I think it's probably beneficial for their lives, but also beneficial for the rest of us, because without that, the church would not survive. So I'm not with you in attacking religion.
Yes, you're not with me. That's quite true. I think it's not a price I...
Can I just say... Yeah, sorry. To give a comment to this, I think of two occasions when popes visited England. In the 1960s, Pope came, and Ian Paisley and his ilk were demonstrated, and they had slogans on their shirts and all that. But when a later Pope came, I saw a picture of you in dark glasses haranguing a crowd, opposing that Pope. And I thought it was rather odd that popes were being criticized from these two opposite perspectives, whereas I would be quite happy to support the Pope, and I'm indeed a member of the Papal Academy of Sciences.
Yes. When you say you're glad there are people who believe it, and because they keep it going and it's good for them, something a little bit patronizing about that, isn't it? Sort of, we don't need this stuff, but it's good that other people do.
Well, I think we might be better if we did believe. I mean, I'm sure I'd behave better if I thought that there was a God watching me.
Oh no, well, I think we really do part company there, Martin.
Yes. I think I would, and I think if we face difficulties, then religion is a genuine comfort to people. And so I would not wish to deprive them of that.
Yes, it is a genuine comfort, I'm sure. But I think, okay, well, let's just agree to differ about that.
Well, the other thing I was going to mention really was where morality comes from. Of course, a religion like Christianity does give strong guidelines as to morality in many areas, which we don't have without a religion. And I think, and this is where I had an argument with Sam Harris, who's one of your so-called four horsemen, I think, who I would describe perhaps less positively as a small-time Bertrand Russell saying again what he was saying. He said that there is a rational morality. And I contested that because you can certainly test whether a moral system is self-consistent. And it's not rational, clearly, if it's not self-consistent. But there are many, many moral issues where we have to make some decision. You can't say one is more rational than another. And this includes many of the very important ones, like should we keep alive babies that will have a limited and unhappy life? And what about assisted dying and all these things? And there's other issues which are deeply important to individuals and where we need some sort of guidance and some judgment. There's nothing more rational about keeping babies alive at all costs and deciding that beyond a certain point you shouldn't, and nothing more rational about different attitudes to death. And so I think the idea that we can get morality from reason is not enough to actually establish a moral system.
The discipline of moral philosophy is always all about self-consistency. And it is true that Sam Harris is a bit out on a limb when he thinks you don't need any kind of premises. But really, you can go an awful long way with moral philosophy looking for self-consistency. I'm really rather appalled that you think that we actually need religion to do morality. When you think about if you actually read the Bible and think about the morality that you would get from reading the Bible, it's not a pretty sight. And I don't think you really can mean that you get your morality from the Judeo-Christian tradition. And I rather hope you don't mean you get it from fear of God. Not you don't, obviously, but that it's somehow praiseworthy to get it from a sort of policeman in the sky that's looking into your thoughts and policing you, disciplining you.
Yes. No, I wasn't saying it was praiseworthy, but I am saying that there are some people who, if they adhere to a religion which we prefer, like Christianity rather than Islam, they may have a morality and a motive to obey it, which is a stronger motive than we can have just depending on reason and custom. So I think there are cases when it motivates people to behave better, to give their lives for others and things of that kind. I'm saying that insofar as we need a religion in order to motivate those acts of heroism and also to motivate thoughts about what to do about the disabled and all that, then we should not want to actually rubbish the views that lead people to those feelings.
Yes, but when you look at the moral lessons you could get from the Bible, how do you choose which are the nice verses?
Yes. No, I agree that one won't get a morality that we would admire by taking the Bible wholesale, obviously.
But when you say you don't take it wholesale, you have to make a decision which bits you take, and that's based upon secular moral philosophy, isn't it? I mean, you reject the verses about stoning adulteresses to death on modern secular moral grounds.
No, I think we do have, we've changed our morality, and there isn't very much that we would want to adopt directly from the Bible. But I think there are some acts which people perform, I mean, acts of sacrifice, which they may perform only because they believe in a God or an afterlife or something like that.
Yes, that's possibly true. I mean, people do make heroic acts of sacrifice for reasons of patriotism and other motives as well. Could I move on to back to astronomy and I'll ask you some technical questions which puzzle me? When we backtrack from Hubble's law to make the origin of the universe a point source, I find it impossible to understand how it can be a point, not something quite small, but not a point. I mean, how can you pack everything into that? Sorry to be so naive, but how can you pack everything in?
Well, of course, quantum uncertainty coming in practice, but I think you could imagine in 2 dimensions a plane surface which goes on forever, and you could imagine shrinking it down so that if it's made up of tiles, you can shrink them down and they could become arbitrarily small. And that's really what one means. So if one talks about a universe that could even be infinite, then you can have a compression factor such that you can make the whole thing arbitrarily small. And I think that is what is meant. Because in most of the standard cosmologies, we're not in a privileged position. And so everyone sees the universe expanding away from them, roughly speaking. And no one can say they're more at the center than we are. But that's consistent with the idea that we're all at different points on this infinite plane. And as it compresses or shrinks, then we're closer and closer together. And so in a sense, they're all at the same point in the limits. But it still allows everyone to be there.
But all the matter and all the atoms in the universe, all the particles compressed into one point. Is that what we're asked to believe?
No, but the particles we know of aren't really there at that early time. It's exotic. Yes, well, to be slightly more specific, I would say on the basis of physics, we are fairly confident we understand. We can go back to the universe has roughly nuclear densities, and it's then at a temperature of about 10 GeV, which is about the energy you can get out of an accelerator. And back to that time, we can probably believe we've got confidence in the physics. And that is a time when the presently observable universe would be shrunk to the size of our solar system. And then, so then everything is now up to the limit of what our telescope can see, would be then in something the size of our solar system at nuclear densities. Now, that's a time when the universe was about a microsecond old. It had been expanding for a microsecond. And cosmologists realize that if they want to explain why the universe is expanding, why it's smooth with much fluctuations, and why it has the things in it that it does, they have to go back further and invoke laws of nature we don't yet understand. But it's clear that the particles we know about don't exist then. And if you've probably heard talk about an inflationary universe, where the universe expands very suddenly. And that process happens when the universe is not merely only a microsecond old, but only 10 to the minus 36 seconds old, and really, really tiny, really microscopic. But the physics is very exotic indeed, obviously.
Yes. Well, a more technical question, I suppose. The evidence for planets around other stars, which I find very exciting, and filling in the missing terms of the Drake equation. the thing about the Doppler shift as a star is pushed back and forth as a planet, as a large planet orbits around it. I'm astonished that the Doppler shift is enough to be picked up. I mean, does that mean that, say, when the Earth in its orbit around the sun is rushing towards a particular star, the color we see of that star will be different from when the Earth is rushing away from that star at the opposite side of its orbit around the sun?
No, that's very small. And of course, the technique of inferring a planet from the wobble in the star it's orbiting, that was indeed used in 1995 to discover the first convincing exoplanet. This was my now colleague Didier Queloz and his supervisor in Geneva. They did this, but for the reasons that you've inferred, they were only able to do this for a planet which was the mass of Jupiter and so close to its star that it orbited once every 4 days. And obviously, having a massive planet close in, that increased the size of the wobble. And so they were able to detect that wobble, but that would not be the way in which you can detect an Earth orbiting. And so most of it's discovered, and the reason that we have these statistics of most stars having them and one star in six having one like the Earth orbiting around it has come mainly from a different technique, which is looking for transits. Yes, and of course, in the cases when we are looking in the plane of the orbits, then when the star transits in front of, when the planet transits in front of the star, it blocks out a bit of the starlight. And for instance, if you were looking at the solar system far away, when the Earth transits across the sun, it makes the sun fainter by about 1 part in 10,000 because the Earth's diameter is about 1% of the sun's, so it blocks out 1 part in 10 to the fourth of the sun's area. But that can be observed. And the most successful space instrument for detecting planets is something called the Kepler spacecraft, which observed 100,000 stars regularly every hour or so with a precision of measuring the brightness of 1 part in 10 to the fifth. And so it was able to look for cases when you saw a dip which occurred regularly. And so from that data, you could infer how big the planet was from the amplitude of the dip when it was blocking out a part of the sun, and also the length of its year from the interval between successive dips. And so that's been the most fruitful way for finding planets. But of course, the planets are all very, very faint. If we were looking at the solar system from far away, the sun would look an ordinary star, and the Earth would look, in Carl Sagan's nice phrase, a pale blue dot, very close in the sky to its star, our sun, but billions of times fainter. And the exciting thing is that with the James Webb Telescope, and even more with the giant telescope being built by European scientists in Chile at the moment, it will be possible to detect the light from one of these planets orbiting another star, even though it's far, far fainter than a star. And if that can be done, one can learn something about its composition. Is the oxygen there? Is there lots of chlorophyll and things like that? So one can learn something. And to take an example also, if there were aliens looking at our Earth with that sort of equipment, they would see the pale blue dot, but the shade of blue will be slightly different, depending on whether they were seeing the Pacific Ocean or the Eurasian landmass. And so they could infer that there were continents and oceans, and that the length of the day and something of the climate and the vegetation on the Earth. And so that's the kind of thing which realistically we expect to do in the next 20 years or so. And it is indeed very exciting.
It certainly is, and very hard to believe it's possible to make such precise measurements. I'd like to end with a quotation from Einstein, who said the most incomprehensible thing about the world, meaning the universe, is that it is comprehensible. I can't imagine what a universe would be like if it were not comprehensible. How could it not be comprehensible?
Well, you probably couldn't do this, but I suppose you could imagine a sort of anarchic universe where the atoms in the next galaxy obey different laws from the ones in our galaxy, or something like that. And of course, it's only been possible to understand the distant universe because nuclear and atomic physics are the same, and we can interpret spectra and all that. And the galaxies are all basically like each other. So I suppose something would be incomprehensible if it was sort of anarchic in its laws and they weren't universal over the region we could study. But also, I think, as you said earlier on, there's the issue that our brains haven't changed very much since our ancestors roamed the African savannah, but we can at least comprehend some features of the very small and the very large. And of course, we can do this only because we can devise instruments to enhance our natural senses.
Yes, if he'd said the most incomprehensible thing is that we can comprehend it, that I would have got. But the idea of an anarchic universe is hardly what I would call the default assumption. I thought it would be more expected to have a universe that has some sort of rationality to it. Anyway, Martin, it's been a real pleasure to talk to you, and it's been a most inspiring time for me to listen to you. So thank you very, very much for taking part.
Right, well, thank you for all your talks and all your books and for doing this. And I hope this is clear. I'm sorry the optics and the technology isn't optimum for this interview, but I hope it's been good enough.
If you enjoyed this episode, you can show some support by subscribing to the podcast, sharing it with your friends, and leaving a review.